Hi, everybody. Look what I got for Father's Day. Gee, just real quick. A travel mug. I just learned this word today. Travel, travel, travel mug. We call this a totally different name in Portuguese, but this is what I got from Father's Day. And I also got my son's draws about everything he likes to do with me, play video games, and he drew things that I love: hamburgers, Doritos, my books. This is me. This is me. It's me sitting in a chair because he knows I like to contemplate the sun. I like to sit in my chair to see this relax, just chill. This is what I like to do. I'm a kind of an introvert person. My son drove me like I am. So it's really special for me because um, I'm a stepdad, right? And I have a lot of daddy issues in my life. So being a stepdad is a big challenge for me because it's really hard to teach something you didn't learn from your father. You know what I mean? So it's really special. Today is yesterday, and all these years has been really special for me. It's really challenging, but also a gift. And I'm glad to have this opportunity to learn with the kid and to learn how to love a kid and also accept his love because I have a lot of conflicts with this. I didn't accept other people's love because I didn't love myself too much, I guess. But a nice day, nice gift. Travel mug, the English word for today. Welcome to a new episode of Brain Training, a place where I train my English while I'm explaining LeetCode solutions. And for today's session, we're going to tackle the two sum. Let's give this a try. Here we got the two sum, the most popular question at the entire website. There's a bunch of you can see here that is a bunch of people online right now doing this question. The first thing I will do here is copy the first example and explain what is the problem requirements and its acceptance criteria. The problem gives us two informations: a array of integers and a target integer. And what the problem wants from us is the two numbers, the position of the two numbers that add up to the target. So in order to do that, we have to iterate over the entire array, make the combinations, and check whether or not they are equal to target. So here we can see that the position 0 and 1 have the two numbers that add up to the target. 2 plus 7. So we should return the position of those two numbers. Let's see another example. Let me zoom in this real quick. For this example, the target's number is 6. So we should find the location of the two numbers that add up to the target. In this case, the location are 1 and 2 because 2 plus 4 is equals 6. This is the problem requirement, and this is how we're going to solve this problem. Is iterating over the entire array, looking for the combination that is equal to target. And to help us with that, we're going to use our good old nested loop. The code will go like this. Here we have the outer loop picking the next number in the iteration, and then the inner loop in charge of all the combinations with that specific number. The inner loop will combine all the remaining numbers after the one we just picked in the outer loop and then check whether or not this combination is equal target. If so, we will return the both indexes. Otherwise, we keep going with the entire loop up until the end. If we didn't find anything, we just return an empty array. That's the entire algorithm to take care of this problem. Let's give this a try and see what we got. And not a bad performance. You can see that we are right in the middle. Not a bad performance. But the problem with this algorithm is that it's doing too much repetitions. In other words, we have a time complexity in square. What that means is for every item here in this nums array, we are looking at all the remaining items. We are doing n times n comparisons. For a space complexity, though, we have a nice constant time because no extra space is required. But we can improve this algorithm. We should improve this algorithm because the experts, they don't like the solution. First thing we do to improve this, it's not a trivial solution, I might say. I don't find the optimal solution easy to understand because the first thing we should do is get rid of all this and see the problem, the problem statement as an equation. That's the tricky part. You should translate the problem as an equation. So in this problem, we have what we want is the two numbers that add up to the target. So two numbers that when we add them, they will gonna be equal to target. This is the equivalent equation for this problem. So we should have to keep that in mind. Secondly, you should know that you already have two informations here. You already have the x variable because will be like a nums in the specific index, and you also have the target information because it's passed as parameter in this function. So we already have two informations. So the actual equation we want is what is y in this equation. And by using the equation properties, you have the formula to find this y variable. It's pure math, the improvement. So this is why I say this is not trivial, especially for myself that, school was not my strength. But with that in mind, we can also improve this, make this even easier to understand, calling the variables other names like complement is equal to target minus n, because y is nothing but the number that completes the sum, our current sum. So we can call it complement. It's just the number that will complete the sum. This is what we are looking for. This is the shift of mentality you have to have in order to improve this algorithm. And the next question is, what are we going to do with this complement? How are we going to find this complement? We will ask, did we see this complement before in this for loop? Because we are in the loop. So we are start a loop like this. Let's say we start a loop like this. The traditional loop in Kotlin. And here we start by computing the complement we want to check. We want to check if we've seen this number before, and that in this moment over here. Because here, in any point in this for loop, we already have the nums, one variable here, the x variable, and also the targets. So we can check whether or not we already seen this complement. And the data structure to keep track of all the elements we have seen so far in this for loop would be the hash table or hash map. So here, the hash map. But what's going to be the key and the value of this hash map? That's also a really good question. Because if you know, yeah, hash maps are data structures that store values with keys so we can retrieve those informations really fast. And the key will be an integer, and the value will be an integer. Because in order to retrieve the complement, the missing part of this sum, we should use the numbers we have seen as key, and the value will be the index of this number. It's not that so trivial to think like this. Let me show what I meant. So we have our scene hash map over here, and the key will be the number we've seen, and the value will be its index. This is how we're going to keep track of the numbers we saw in this for loop. All the numbers we went through, in other words. Another thing to keep in mind is that we're going to save after we compute the complement, because we should say we already seen this number before back in a previous iteration. So what we're going to do is just return the index of both numbers. Complement. So here we're going to retrieve the value for this key that will be the index of this complement. So we double bang here because Kotlin hash maps in Kotlin, they have a null as the full value. We just saying to the compiler that we know for sure that we have a value here. And we also have to return the index of the current number we are looking at. Otherwise, if we didn't see the complement in this hash map, we have to keep track of it. Here is another trick part, because what we want to save here is the current number we are looking at. Don't mistake by the complement. Complements compute in every single iteration. But if we don't find any complement for this equation over here, we have to save the current number we are checking in, and we use the number as the key, and we save it index. That's what we do it. And in case we don't find anything, we will return an empty array as well. It's not that easy to come up with this solution on your own. Not gonna lie. The person that came up with this is a really smart guy or girl. Who knows? Let's give this a try and see if I didn't mess anything up. And look, the improvement. Again, not an easy solution to come up with, but once you understand all those steps and how the translation you should do in order to implement the improvement, makes a lot of sense. It's quite nice to see. In Kotlin, we can make this look a little better by using yet another for loop like this, a for loop that uses tuples. So here in each iteration, we already have the number and its index. Again, just use n. That will make our code look a little better, I guess. This is the improvement we got here. So in the end of the day, we have the same line. Let me just check in if this is correct. Yeah, same performance, a little bit cleaner. Now for time complexity, we got the good old linear big O notation. Just a single for loop, get the job done. We don't need nested loops. We don't need to do all possible combinations. We just go over once in the entire array, and in each iteration we compute the missing portion and check in our hash map whether or not we already have seen the number that will complete the sum. If so, we just return both positions or indexes, if you will. But the trade-off is on space complexity. Nothing is free. Nothing is free. Now, we will also have the linear time complexity for space because we are using extra memory. We have to create this data structure and keep track of all numbers in nums array in the worst case scenario. The scenario where the two numbers are in the end of this nums array. And there we have it, guys. Choose sum. Completely explain clearly as possible. I hope I accomplished the nice and clean explanation because it's really hard to explain this, especially in English. But anyway, hope you like it. See you in the next video. Bye bye.